10.2 notes, law of cosines. This is page 5. So everything on this page is an application problem. So let's just dive right in. Example 7. We got a Chicago city developer who wants to construct a building consisting of artist lofts on a triangular lot bordered by Rush Street, Wabash Street, and Pearson Street. The frontage listed along each of those roads is given. 62.4 along Rush Street, 43.5 along Wabash, and 31.4 along Pearson Street. We want to know how many square meters are available to the developer. Now, keep in mind, he wants to develop that triangle to build on. So we are looking for the total area. So we're going to go back to Heron's formula. We're going to start by finding that semi-perimeter. We have 62.4 plus 43.5 plus 34.1. We're going to add those together and then divide by 2. So we get what? 140 over 2. So this is 70. So our area, which is the square root of S times S minus 62.4 I'll stick all these in here, times 70 minus 43.5 and times 70 minus 34.1. We're looking for the square root of 506,118.2. So we've got roughly 711.42, so 2 decimal places, square meters. So make sure that as you read through these, you know what you are being asked for. Example 8, we've got a surveyor is taking measurements, find the distance across the lake. So what we are looking for now is this total distance. So let's go ahead and label this side C. That makes this angle C. And these are A and B, and it doesn't really matter which one's which. So we want the length of C, so we're going to go back to the law of cosines. It's this length across the lake that I'm looking for. So that's my C squared. We've got equals A squared plus B squared minus 2AB times the cosine of C. So 800 squared plus 900 squared minus 2, A is still 800, B is still 900, cosine of 70 degrees. We crank that out and we get C squared is 957,490.99. Could round that up here, might as well just let that go at this point. We can round at the end. We get C is approximately 978.5 feet. Example 9. This one's a little different, and depending what text we're looking at, you may or may not see problems that deal with bearings. Okay, so let's talk about what we've got to start. I'm starting at city A. And I'm going to put city A right here. So we fly from city A to city B with a bearing north 28 east. So again, straight up is our north. West is to the left, east is to the right. And so we're 28 degrees to the east off of north. And so here's my 28 degrees. This length is 710 miles. And this is city B. Then it flies, 672 miles from city B to city C with a bearing of north 45 east. And so here's the thing. From city B, I'm going to go ahead and draw in second set of axes. We've got north, again this direction, 45 east. And here's my city C. And we've got, what, 672 miles along this one. So I want the straight line distance from city C to city A. So I am looking for this length, which means I've got this obtuse triangle. I don't know what this angle is, so I kind of got to figure that out. So let's go with, how can we do this? Let's drop this right triangle. So if this is 28 degrees here, this is 90, that makes this 62, which makes this little bit in here 28 degrees as well. From city B to city C, I know that this is a right angle here. If I've got 45 degrees here, that means this part in here is also 45 degrees. And then this last chunk is going to be a 90-degree angle. So we can add those all together, and we've got this angle in here, 45 plus 90 plus 28 is a 163-degree angle. And if we're calling, well, that's city B, so we might as well call that vertex B, which makes this side little b. And so now we've got b squared equals a squared plus c squared minus 2ac times the cosine of b. We're using the law of cosines because we've got two sides and the angle between it. So angle A, this little one down in the corner, we don't even know how big it is, but we do know that the side opposite it is the 672 miles. Angle C, our little acute angle up in the corner, opposite our 710-degree side, minus 2 times 672 times 710 times the cosine of 163. All that through the calculator, and we get 1,868,228. I realize my commas don't look like commas. 0.25. Now let's be realized if we're talking in the millions here, that 0.25 doesn't really matter, but I've already written it, so I'm not going to erase it. Square root both sides, and we get the length of B is approximately 1,366.83. So we got approximately 1,367 miles, which is the straight line distance from city C to city A.